best alternative because it has the rank 1 or the highest closeness coefficient. Okay, now by closeness I mean closeness to the positive ideal solution and furthest from the worst ideal solution. Okay, so this is what is a process, the 6-step process to find the best alternative from a group of alternatives with the help of TOPSIS method. Now the next few slides will show an example, but I have already discussed or tried to explain with an example, and I think it is self-explanatory. Always remember that when deducting PIS, positive ideal solution, you deduct it from each of the value of alternatives for C1, and in case of C1, the positive ideal solution will be for C1 only, not C2. Sorry. In case of C2, the positive ideal solution will be for C2 only, not C1. That you must remember. Same for NIS. NIS for C1 only, NIS for C2 only. And you will deduct this PIS or positive ideal solution from each of the values of alternative with respect to C1, then square them, and then you add the exact thing, deduction of positive ideal solution and squaring of that deducted value for C2. So you will add both of them, C1, so value of C1 and value of C2, and whatever value you get, here I have indicated them or referred them as A, you would square root them to find the D. Find the value of D, superscript plus, this plus indicates PIS or positive ideal solution, and subscript I indicates the number of alternatives. In our case, first alternative, second alternative, third alternative. So similarly, when it is superscript minus, you have to deduct the NIS for each of the alternative for each of the criteria, and you will get the D superscript minus subscript I. And to find the closeness coefficient of each of the alternative, remember, this is a very common confusion. Closeness coefficient is to be calculated for each of the alternative. Each of the alternative. Okay, each of the alternative, that is CI. How to calculate? DI square root superscript minus, that means the negative ideal solution deductions, divided by the summation of the positive ideal solution deduction and negative ideal solution deduction. This D is actually indicate the distance from the ideal solution. For positive ideal solution it is plus, for negative ideal solution it is minus. Okay, so for each alternative you get closeness coefficient. Compare the closeness coefficient. The alternative with the highest closeness coefficient wins the race. That means the alternative with the highest closeness coefficient is the selected alternative, the best alternative among the available alternatives. In our case, there are 3 alternatives. C1 has the, or A1 has the highest closeness coefficient, as I have assumed, or as I have given, 0.801. So it is the best alternative among A1, A2, A3. Correct? So this is a very simple example given, but I have already discussed about this example. Not this, it is a separate example, but I have explained you the topic, the method, with the help of another very simple solution. So here also you see C1. In this case, their criteria is efficiency, capacity, cost, and emissions. As you see, more the cost, less is the preference, more the emission, less is the preference, because emission is not acceptable criteria. That means if you emit more, you pollute more. So that is not expected. To save our environment, we must reduce emissions. Okay, so that is why emission is also a cost criteria. Cost is of course cost criteria. Capacity is of course benefit criteria. More the capacity, better is the preference. If a machine has a greater capacity, you will always prefer that. And efficiency means working efficiency, operational efficiency, whatever you may say. Any kind of efficiencies, more efficiency is preferred, right? If your machine has a good working efficiency, you will always prefer that machine over a machine which does not have a good efficiency. It is implied, more or less. Now, what they done is that they have first assigned the weights. These weights are assigned by the decision maker group or decision makers, but you can also assign them with the help of HP or entropy methods, whatever you might say. Both are correct. Direct weighting and always HP or entropy based weighting. Both are acceptable. Now, but you see here also the weight, the summation of all the weights assigned to all the criteria is 1. So 0.3 plus 0.2525 means it is 0.5. So 0.5 plus 0.3, 8 plus 0.2 is 1. Okay, and these are the values of the alternatives. There are 4 alternatives, A1, A2, A3, A4. For C1, the values is given, C2 values is given, and such, and so on. After then, they will normalize the matrix. We already discussed this, normalized the matrix. What you do, you square each of the term, correct? You have to square each of the term and add them.